It's an intermolecular force of what? Attraction. So van der Waals forces. Van der Waals is simply known as the weak, short-range, electrostatic, attractive forces between uncharged molecules arising from the interaction of what? The dipole moment. Take note of that. The dipole as a result of what? If you are having H2, it is a dipole. The dipole is H. This one is what? Positively charged. This one is negatively charged. So this is what is known as what? A dipole moment. So take note of that. That is what? Van der Waals forces. And you see it in iodine, naphthalene, ammonium chloride, and the likes. Then let's look at deduced bond types based on electron configuration. Yes, you can also use electron configuration to deduce the bond type. Let's say 2,8,8,1. What is that? That is 19. That is potassium. Potassium will definitely what? Undergo ionic or electrovalent bond with ease, simply because it has only one electron in the outermost shell, which it can donate easily. So that is why potassium will definitely what? Undergo ionic bonding with ease. So you can see how I've been able to use electron configuration to predict the bond type of. So if you have potassium with any other metal, non-metal in this regard, so if they ask you that what kind of bonding is this compound undergoing, it should definitely be what? An electrovalent bonding, simply because in the case of potassium is what? 2,8,8,1, and chlorine is what? 2,8,7. Potassium is working towards stability, and you can only be stable at duplet state or an octet state. So in that situation, but because of the fact that this is the electron configuration of potassium will prefer to lose this so that it becomes K plus, and K plus is 2,8,8. Now it is now stable. K plus is more stable than what? K, because at this state it has attained stability, that is the octet state. Then also chlorine will also be working towards stability at the what? Octet state. So Cl minus will now be what? 2,8,8. So what is happening here is that the electron that the valence electron on the what? On the potassium has been transferred. So that's why the 7 is now becoming what? 8. So in that situation, this is a typical example of what? An electrovalent combination. So that is how one can use electron configuration to predict the bond type of a compound. Then also relate the nature of bonding to properties of compounds. Now, when you have this, because of the fact that it is undergoing what? Ionic bonding. And before there can be ionic bonding, that means the difference in the electronegativity, potassium and chlorine, is very high, very high. So when you have a very high electronegative value difference, it is definitely going to be what? Ionic. That means such a molecule will be what? Polar. And when it's polar, that means it will dissolve in water. Take note of that. So you have that analogy there. So when you have a very high electronegative values difference, then it is what? Ionic, that is polar. But when there is a small electronegative value difference, it will be what? Covalent. Take note of that fact also. Then apply it in everyday chemistry. So it can be applied in everyday chemistry. When you see a compound, you can easily predict by virtue of the way they combine. You can say that okay, this is definitely what? An electrovalent combination or bonding, an ionic bonding, and the likes. Another concept of coordinate covalent bonding is using Lewis concept. So where you have an ion, to be precise, a metal ion, and a nucleophile. So a good example of that is Fe2+ and your cyano, which is minus. So if you look at this, the combination of this with this is definitely going to be what? It's also another form of what? Covalent combination. Take note of that, where this one is the acceptor of electron and this one is the donor of electron. So a nucleophile is a species that are negatively charged or having a deficient, efficient, electron efficient species, and what? Or negatively charged species, or electron efficient species and negatively charged species. So that is what makes this a nucleophile, because it is what? Negatively charged. So if they want to combine now, they can combine in this form. So plus 3 of this now, it will make this. Then you have Fe, trying to calculate this and see whether it will work. Plus 3. And ion here will be, it's minus, and minus. Okay? So that's the compound. This kind of combination is known as what? Dative or coordinate covalent combination also. I just want to activate your mind on this also, because this can also be what? It's either between a metal ion, which is an acceptor of electron, and what? A nucleophile. It's also an example of what? Coordinate covalent combination. So let's see some questions to really appreciate the beauty of what we are talking about. UTME question designed for this topic. We have question 1. The idea of planetary electrons was that of A. Bohr, B. Thomson, C. Rutherford, then D. Dalton. First and foremost, when you talk about Bohr, it can never be Bohr, simply because Bohr only works on what? Hydrogen spectrum, and electron is restricted to what? A certain energy level. So it cannot be Bohr. Then the second one is Thomson. Thomson does not work on planetary electrons, and that was established in the previous slide, where I talked about how different scientists carried out different experiments and contribute their quota to development of particles, atoms. But Rutherford, yes, Rutherford specifically work on planetary electrons. Then Dalton can never be, Thomson can never be, Dalton can never be too, simply because Dalton only work on what? Theory of atomic theory. It never worked on planetary electrons. Thomson worked on, it considered a sphere which contains positively charged protons and electrons embedded. So it never worked on what? Planetary electrons. The only person, and then John Dalton only worked on atomic theory. So this one is also out. This one is also out. So the suitable one is Rutherford, that worked specifically on what? Planetary electrons. Question 2. Which experiment led to the measurement of charge on a molecule? The only person that performed that, the charge on an electron, is Millikan. And is working on oil drop what? Experiment. Take note of that. Oil drop experiment. So let's see our option and see the one that matches that. Option A, scattering alpha particles. No. Option B, discharge tube experiment. No. Option C, oil drop experiment. That's correct. So that is what Millikan work on. Charge of electron with in relation of this oil drop experiment, and that's the answer. The D, mass spectrometric experiment. No. That one is to determine the molecular mass. Then question 3. The experiment that showed that atoms have tiny positively charged nucleus was first carried out by A. Mosley,